Yep, already. So let me do the live now tweet. Here we go. Oh, wow. Notifications already blowing up. Chris Cornut already chiming on Twitter is wanting to catch it live, but unfortunately he's not able to join. He says, I guess I'll just have to settle for it after the fact. We'll miss you, Chris. He's going to be on an episode pretty soon, so he'll be in a live episode very soon. Thanks for joining us once again. I'm Sammy K. Powers, and this is the PHP Roundtable, which is a live podcast of developers discussing topics that PHP nerds care about. The ultimate goal of this podcast is to learn a little something from each other. If you're listening live and want to be a little part of this shindig, send a tweet to PHP Roundtable with a question or snarky comment, and we'll get your question and or snarky comment addressed live on air if we can. A little status update on the PHP Roundtable elephants. If you missed the big announcement, PHP Roundtable, this little podcast you're listening to right now, has its very own elephant. Yes, listen to episode 72, which is the one right before this, for all the details on it. But I just wanted to give you a little bit of a status update. I wanted to give away as many of these little things as possible, so I made a bunch of them available for user groups and PHP events as raffles and giveaways, and I was completely swamped with the overwhelming responses from user group admins and all these people from around the world. But I'm proud to say that as of yesterday, I was able to clear out my inbox of all the requests. So if you requested an elephant for your user group or your PHP event, you should have a response from me sitting in your email inbox. But I also wanted to point out that the elephants that were set aside for PHP user groups and PHP events have all been claimed, and most of them have already been shipped out. My girlfriend, Heather, back here, she gets a huge mad props for helping me stuff the packages yesterday. So if you were one of the lucky user groups or PHP events to claim one of the elephants, your package is on its way to you. Now, the thing is, the most of the lucky user groups were outside of the States, which made the shipping pretty dang expensive for me coming from the States. $292.84 was the grand total to ship out all those free elephants. So I posted on Tweeterville or Twitterland yesterday to ask if anybody would be willing to sponsor half of the shipping costs in exchange for a PHP Roundtable elephant. And by this morning, there were 2 potential sponsors already ready to pay for that. And one of them still pending, but the other one was Mark Baker. So huge shout out to Mark Baker for sponsoring a big chunk of the shipping costs. And it's because of Mark's help that we were able to send out these elephants to get people from around the world an elephant. Maybe it's their very first one. So he's Mark_Baker on Twitter. So join me in giving him some mad Twitter love, especially if you are one of the lucky user groups getting an elephant. And Mark, I dropped your PHP Roundtable elephant in the mail today, so you should be getting it hopefully pretty soon. One last thing. All this means is that there's a lot of user groups out there now that have a PHP Roundtable elephant waiting to be given away and raffled off. So if you want to get one, make sure you go to your local user group, because your group might just have one of the elephants to give away, and you might just get it. So that would be sweet. All right, that's my status update for the PHP Roundtable elephant. Now let's see what we're actually talking about today. Static analysis. What is that? Static analysis is a fancy word to describe a tool that basically looks at your code and gives you some helpful hints on how to improve it. The PHP community has a rich set of static analyzers to choose from, and today we are discussing some details about what these nifty little tools do and how we might be able to incorporate the tools into our daily development flow. Now that we know what we're talking about, let's meet our panel. And as always, in no particular order, we have Ondřej Mirtes, who is the creator of PHP Stan and tries to make a living by developing open source. He is currently obsessed with continuous delivery and travels to conferences around Europe to share his experiences as CTO. There he offers his expertise as a consultant and organizes trainings. Welcome, Ondřej.
Hello, really glad to be here.
Absolutely. We also have Craig Duncan coming back for another round. He is an avid open source contributor, rather. He maintains a bunch of his own open source libraries and recently took over development of PHP League's climate package. He also dips into PHP internals from time to time, fixing bugs and adding some improvements to the language. And he is the one that we blame so hard in the episode 71 for breaking all the things in PHP 7.2. Welcome back, Craig.
Hi, great to be back. Thanks for having me.
Absolutely. And we have Vladimir Reznichenko. Am I close?
Almost. All good. Hi. Thank you.
How would you pronounce it?
Reznichenko.
Oh, that's beautiful. I wish I could say it as beautifully as you say it. Vladimir is writing static code analyzers for PHP Storm and IntelliJ IDEA. Welcome, Vladimir.
Thank you. Happy to join the round.
Absolutely. And finally, we have Damien Seguy, lead developer for Execat Static Analyzer and the proud owner of an elephant herd that has elephant number 0? No bum tag. Is that right?
It's actually we call him the Trizalayer, the great-grandfather, if you really want.
Ah, ooh, nice. That sounds very valuable. Absolutely. Thank you for coming on. Thank you all for coming on. We got a lot to talk about. Wow. So static analyzers. So we know that there's these tools that help us look at our code. That's kind of the higher up look at it. But not all static analyzers are the same, right? There's a bunch of different types.
Yes, correct. Especially in PHP community, basically we have really a lot of analyzers, different types. Maybe just some things like from code style to some really security issues. It's really wide range.
Yeah, if you simply look at the 3 static analyzers for which we have authored tonight, some of them run in command line, others run directly in the IDE, others run and produce audits. So there's both in the way in the fields where they apply and the way they run, they are very, very different. For those of you who want to try to look for a static analyzer, my current list has 90 of them listed together with different applications and different way of running. So there's a lot of choice for everyone.
Yeah, and each of them have different, let's say, frequency, how often you should run them. So some of them you run occasionally on a code base just to check that everything's fine and no area is growing too fast and everything is decoupled. And some of them you, for example, run when you inherited a legacy code base and you want to see which place to refactor first or how good the code is. And some analyzers are meant to be run in continuous integration on every build, and they are best suited to run besides tests to see if there's any bug.
That's great. So what are some of the things that static analyzers typically find in our code that like, what's the kind of like the point? Say someone's never used a static analyzer, what can they expect to kind of uncover from their code that maybe they never realized before?
Yes, so static analyzers can find potential bugs that can, for example, manifest that are finding a potential bug. That means that the code might be fine as it is, but for example, if you pass a different parameter to a function than you are passing now, then the function might crash, or the bug can be more obvious that it will always crash and the code isn't executed, or it's just a bug that to be found by the developer or by the user. Other static analyzers can find security vulnerabilities. So for example, they can recognize if your code is prone to SQL injection, or some static analyzers can find code with different formatting than your team agreed upon. So they are coding standard checkers, and other analyzers can, for example, find some code smells like some function is too long, or you are not using not enough descriptive names, etc.
Yeah, I like to see that as a progression. Usually people come to static analysis for bugs, so things that are really polluting your code. And then there's kind of a progression. From bugs, you go to clean code, removing things like dead code, the things that should not be in the current source base. And then you may think about improvement. So, for example, very classic one, if you're not used to if you don't know about array column, the static analyzer can be able to detect that pattern and tell you that you should improve your code with that. From there, you can go to what I call local idioms, which is basically the way you practice PHP in your team or in your company. Just like if you think about it, English may have different dialect depending on the North American, the Canadian one, the British, or whatever. There are little differences that are specific to the country. Well, that's probably the same here. And with static analysis, you can actually look at that and know what are the local preferences and things you do and you don't. And finally, just looking at the code, reviewing it, well, you learn a lot of things that can be extracted and documented, like automatic documentation extracted from the code to tell you which extension to compile, which version it's compatible with, or so. So there's a wide range of tasks that static analysis can undertake.
Yeah, also some interesting use cases just from my practice. We run in the IDE, and what I get feedback from the people often that juniors really start learning new features fast. So we have some group as language level migration, which basically teaches the dog new tricks, and that's super productive for the juniors to learn the language. When your skills are outdated, it was 10 years for Java, want to try PHP. The learning curve goes really fast also with static code analysis.
That's really cool. So is the ultimate goal to run a static analyzer in our code base, have it give us all these really cool ideas to make our code better and get our code up to snuff, like get it a clean bill of health so that you're basically passing 100% of all the static analyzer tests?
That's a challenging task. I guess everyone's going to agree on that.
That's not possible. Currently, I count something like above 600 analyses with Exacat, so that's a long time just to review all of them. And what I like to mention is also I have some of them that are kind of contrary one to each other. For example, there is one that will spot what I call single usage variable. You say, you take a value, you put it into a variable, the next line you put the variable into a string, and that's done. And in the same time, there's another one that tells you that the expression is too complex. And at that point, either you want to remove all those single-use variables, but you may end up with a huge and very complex expression, or you want to remove the complex expression, and then you will end up lots of readability single-use variable. So it's not possible. What is sure is you have to make a choice. And I think that most of the static analyzer provide you with a reference, make your choice, cherry pick every single analysis that's important to you, and then use them. There you can reach 100%.
So for static analysis tools that are meant to be run as part of CI, like PHP Stan, you should configure it in a way that the build is green, that it passes, that it exits with code 0 on the command line, so that there shouldn't be any errors or warnings. Of course, it usually means that you have to ignore some errors so that it passes, but you should make sure that it actually checks something.
Gotcha. So as part of, like, as you mentioned, a continuous integration setup, if you wanted to have that automatic code analysis going on, if I have a code base that's sort of stuck in one of those situations where it was like, now I've got all these like single-use variables versus this is too complex, how do I get it so that it does return green? I've chosen, like, I want a bunch of like single-use variables, but I still need this to return green every time I want to deploy. How do you alleviate that particular situation?
Well, usually, since those two forces are pushing one direction or the other, you have to make a choice. What is the important? Do you care about having more variables, or do you want the code to be more readable? Most of the time, you end up with focusing on what's important to the developer and what's human readable. So, yeah, that's the static analysis make the link between the code, I would say assembly if we want to be really technical, but really the code and things that we can use and we can understand. So whenever there is a choice, anything that's around human nature is probably the best guess.
Yes.
So
also,
sorry.
Yeah. I just wanted to say that generally each analyzer comes with default rules. Normally, in analyzer, in my case, I guess, in case of Damien, there are some analyzers which are there, but they kind of rejected in a while, and they disable default configuration. So you can both way. You can disable some rules, which just because we are human, we have opinions, and to sell analyzer to the team, you need to disable something. Or you can enable some rules the same way. So, Ondřej?
So what really worked for me, that if you are standing in front of a decision, you should make a meeting with your team, which is a great reason for get together, and to actually vote what the team prefers in a democratic way. If you are standing, for example, in front of a decision, what code style you should use, where do you want to write your parentheses, etc.
And if there's an error that continues to show up in a particular run, and we've kind of decided, you know what, this is the way it is because of X, Y, and Z reasons, it's always going to show up as an error for the static analyzer. But we also want to add this little step to be checked every time we deploy to production. Is there a way to sort of like say, okay, this section of code, just ignore this for the static analyzer because we made this choice on purpose?
Yes, it should be able to ignore it.
Cool. Now, how do you go about making that decision though? Like, okay, I want to ignore this part, because I'm sure the very first time you run a static analyzer on your code base, if you've never done it before, it's probably going to find 1,000 things wrong, right? And you're like, I'm not going to be able to fix all this before our next deployment, right? So what's the best way to kind of get continuous deployment or a static analyzer into our CI stack?
Well, that was kind of how I stepped into it. At first, finding out about all these tools, I tried to run them, like you say, as part of the CI, and you just get hundreds of errors and don't know where to go. What really helped me was getting it from the IDE. So I started using PHP Storm and the stuff in there. And I just find that's a lot helpful, because you can just do it while you're writing the code. So while you're working on a particular piece of code, your IDE will flag up things, tell you things there and then, and you can fix those. Or while you're working on some legacy code, you can get them flagged up and kind of fix them, kind of do it piecemeal like that, and gradually work towards then introducing it in CI.
Yeah, that's basically Scout rule. So keep the new code clean. And so if we take any code analyzer, which has different things, we have pyramid of different warnings, errors on the top. In the mid, you have warnings, and the weak warnings on the bottom. So if static code analyzer emits the severity, so you know which type of severity is this, you can start with errors for sure, and maybe you get lucky to reach the pyramid bottom and work out the weak warnings. But the real value for the project in short term is to take the pyramid top and recheck, suppress, and clean up this one. That gives tons of value with any analyzer.
Okay, when working with legacy code, I like to usually take two criteria at the same time. One is how easy is the report to be fixed, because one fixed report usually means that's something less to care about. And the other one is how infrequent is this error. So, for example, based on different audits from Exacat, we have a list of all the analysis, and we know how frequent they are. So when an infrequent error strike, it's usually interesting because something really special happens. So I kind of marry both of them. Either it's easy and infrequent, then usually I take a look. If it's just an infrequent or easy, then yeah, there's a choice to be made there.
So if you are looking to incorporate a static analyzer into your continuous integration build, you really want to strive to have a green build as soon as possible. So there are several strategies that you can use. For example, PHP Stan uses strictness levels that are there out of the box, and each level adds new specific checks. So it's really easy to get started and to improve the existing code base based on that. So for example, the first level 0 that runs by default, it only does basic checks like function calls and method calls on types that it can be really sure about. So for example, method calls on this and static calls. And as you increase levels, more involved checks are done. So, for example, on level 2, the PHP docs are started to be validated and checked, and method calls on not just on this but on any object are started to be checked. So you can start with PHP Stand on level 0. You can make it to the Greenfield, merge it to master, run it in your CI continuously. And if you have time, for example, while you are doing, for example, some hackathon or refactoring, you can try to run a higher level and fix errors based on that. Another approach that's completely different is to run the maximum level or run some sane level like level 5 out of 7, and to generate a log file of all reported errors by the tool and version this log file to put it into Git. And you should make sure that this log file stays up to date with each commit. So you should make it part of the diff of your pull request. So the one that is doing the code review of the pull request can see what kind of errors are removed or added with the new code. So that's another way how to kind of keep the reported errors under control. And another most complex approach is to, with a bit more work and configuration, is to mesh more tools together. So you can actually run PHP Stan, and then you can filter the output of the tool by open source package called ReviewDoc that gets your GitHub or Bitbucket credentials, and that can actually report errors only on changed lines and comment them directly in the web user interface. So that's another way how to make use of the static analyzer as soon as possible.
Very cool. I love the idea of starting with like kind of a lower level or strictness for the static analyzer and working your way up. So if you really want to feel good about yourself, start on level 0 where it's only going to find a few errors, right? And then try to run the one with the max level and then feel horrible about yourself because it's finding 1,000 errors. Is that the idea?
Yeah, and it's really hard to achieve the highest levels because it also requires you to write the code in a specific way. So for example, the highest level that was developed based on some feature request was to report that you are calling methods and accessing properties on objects that are possibly null. So for example, if you have a getter, but that getter has a nullable type hint, and then you are calling something directly on the value returns from the getter, you are risking that you will be calling method on a null, which is an error. But the mistake that developers usually do is that there's there's some knowledge that they are applying to the code under development that is not obvious from type hints. So for example, they know that if they first ask the object, for example, hasName, and if the hasName method returns true, that they can safely call getName, and that will never return null, but the static analyzer cannot know that. There's no way, there's no connection between the hasser and the getter. So that's something that will be reported on level 7 if you don't spend more time with configuration or writing some kind of extension that helps PHP Stan understand such code.
Yeah, so that's also, by the way, just a little bit side, but static analyzers generally have also kind of subsplit. Some ones really respect the PHP docs. Some ones rely on the code execution. For us, it was quite hard cut to keep the focus in our project, and we decided to skip the PHP doc related things, and we basically try to analyze the real workflow, real type hints, and kind of we don't trust PHP doc. So that's different for my project and for PHP Stan. I just use it for my projects, and there I have often to really maintain PHP doc, and that's kind of, yeah, challenge for that.
Absolutely. So Vladimir, with your project, you actually your static analyzer integrates directly into specifically PHP Storm, correct?
And IDEA Ultimate.
Very cool. And I really like that it's as simple as right-clicking on your project and saying analyze, right? And it basically just goes through the whole thing and tries to find basically problems with the code, and it just gives you that those type hints or not type hints, those little what do you call them at the bottom? Where it's like you should do this. The notifications.
Hints.
Yeah.
Yeah.
What do I like? Go ahead.
Yeah. So that's I call this real time. That's also when you do development, just you type some code in, it works. It gives you type hints, but also Alt-Enter works for majority of things. So we not only complain, we also fix it. At least I always think it's right. There are some false positive bugs, but in general, that's kind of our superpower. We not complain, we also fix things.
So I noticed that maybe a lot of people are familiar with PHP Storm without the static analysis aspect, but they already get a little bit of static analysis out of the box, right? Like it'll still help you with little things here and there. What is it that adding this plugin will actually enhance versus what's already part of PHP Storm?
It will challenge everyone who dared to install it. Just kidding. So we passed already 4 years development cycle. It was really super opinionated at the beginning. Now we soften the default configuration. So if you install the plugin, you almost have all the sharp corners fixed for you over the 4 years. You get some big portion of bugs, security issues, control flow things. Specifically, control flow helps a little bit better other rules to check your code. So there is a bunch of everything. We try to keep focus, but it's currently bugs, security, and control flow.
That's really cool. So if we were to try to integrate all the things that we've been talking about, if we have the static analyzer in PHP Storm, we analyze our code, we fixed as many of the things that it found as possible, but we also have, say, PHP Stan kind of sitting there between our deployment stack, and it finds slightly different things or is looking at it a slightly different way. How is the best way to sort of address using multiple static analyzers across the board?
I do some cross promotion. So if you use PHP Stan, you have to use PHP Stan, and for reports you have to use Execat. So there is kind of specialization for that. I just can give an example of what I do. Let's say each analyzer has superpower, because we need to analyze what we are good at, what are really demanded on the market, and everyone has these specific features. So you have to combine multiple of them to reach the good result.
Yes, use all of them.
Use all the analyzers.
There are 90 of them at the moment, so it's a really long thing to install all of them. But yeah, it's true also that the different teams will focus on different aspects, and the tools are trying or testing different aspects of the code. So probably you have to choose the one that is most adapted to your situation. And actually, I think this is really exciting in terms of working in that field, because there's lots of different problems to solve. Type hint is one of them. Dependencies inside the code is another one. Supporting legacy code source is another one. And all the tools work differently. So there's no way you can replace one with the other at the moment.
I'm glad you brought that up, because I was really curious about the specific ways that you might use one static analyzer on a Greenfield project that you're starting out fresh, or one that you've inherited. Maybe it's a legacy code base. And kind of before you even look at the code base, do you run a static analyzer on it, or do you start poking around right away? Or what? I'm curious to hear y'all's approach on on a legacy code base.
On the legacy code base, I actually have a very interesting session that I do for an hour, where we actually review some code that is unknown, and we just look at 1 million lines of code without actually looking or knowing whatever about the project. And by the end of the hour, it's very surprising, but you can have a very precise opinion about this piece of code if you want to use it, if you want to take over the maintenance or so. So at the moment, using static analysis to review legacy code is very interesting and saving a lot of time and also building a lot of trust in what you're going to do in a moment. So probably at that point, Exacat is the one that extracts the most documentation from any piece of code and use it as a whole system. So it will probably give you the better foreview and global view of a piece of code. So I think if you're starting from zero, PHP Stan or inspection are really better because then you have a clean code. You can directly choose the most modern approaches and start with 0 errors from the at the bat, as I say. So yeah, that will be the main difference.
It's easiest to start using PHP Stan on the highest level if you have 0 code, so you can start with the strictest approach from the start.
Confirmed. I do this. So we have a Greenfield project. So the first thing I was at CI. So let's say in IDE we can do something, but it's at the way there are some colleagues who don't use PHP Storm. We have to respect that. Not everyone uses IDEs. So we have to integrate something in CI. The Greenfield things was called a style fixer by Darius Rubinsky. So to consolidate the coding style. And PHP Stan 7 version to ensure that from the scratch we enforce type hints, all the things to be done with modern features. So PHP 7 level of PHP Stan saved a few times my builds. So that's for sure. If you take something, take maximum strictness. If you cannot stay on this level, try to relax the level. It's also relates to the my project. So we have some meetups where people just say, okay, that's too complex. We disable the plugin, and then we just end up, okay, disable these groups and keep the probable bugs at least on it. You get profit even on legacy code.
Yeah, so I think that this is where PHP really shines, because when you are combining dynamic language with static analyzer, you can choose which parts of your code you want to check really strictly and where you probably want to be a little bit more loose. So when you compare this to compiled language like Java or C#, you always have to satisfy the compiler with the correct types. But in PHP, you can be a little bit more creative because the language does not limit you that much. But if you run a static analyzer on a code base for a dynamic language, then you are basically getting the same advantages when you are using a compiler for a compiled language.
Would you say static analyzers are specifically more useful in dynamic languages like PHP and JavaScript and things, or is there even any use for static analyzers in more static languages or what do you call them? Strict type languages or static type languages?
Yeah. So in case of PHP Stan, partly it supplies the role of the compiler because PHP doesn't have one. But it isn't true that static language, compiled language, doesn't need a static analyzer, because the compiler has a role to just compile and run your code. But so it does a lot of checks for you, but the static analyzer can do a lot more for you. So the creator of static analyzer can probably think of many more rules than just the developers of the compiler. So I think it's valuable to have static analyzers for both dynamic and static languages.
Yes, I wanted to just basically summarize quite the same, but shortly, that there is for sure a market out there, and actually it's more commercial analyzers. It means topic makes more money. It's more demanded on the markets like C++, on Java. On Java, it's high competition for different static code analyzers. just because of scope, you can find some conditional issues. You can find, in case of C++ with static code analyzer, memory leaks issues. So all these are things which makes or helps production can be normally found in the source code. So that's any programming language where people involved, people do mistakes. Static code analysis can cover this topic.
I just want to give a shout out to Colin Odell, who is watching the PHP Roundtable live on the big screen, sitting there doing development with the PHP Roundtable all large on his big TV. So, hey, Colin. He's also said, speaking of static analyzers, if anyone is working or has a working PHP stand config for Drupal 8, please let me know. So if anybody has that, ping Colin Odell on Twitter. He's wanting to talk with you about it, no doubt. I do want to kind of shift gears a little bit about and looking at the sort of like the when using a static analyzer in our continuous integration, when we have certain things that it's complaining about or things that we haven't gotten a chance to address yet. If we keep seeing these error messages and warnings and messages and notifications all the time about our things that we can improve on our code bases, one of the criticisms is that maybe we just start tuning those out and we just start getting this sort of like white noise of static analyzers equals stuff we can ignore. What are some advice from you all about how we can prevent that from happening, say working with a team of developers who have continuous integration in their continuous development or this continuous integration?
Okay, I think we've already mentioned the fact that there should be kind of levels. So first, among the whole list of tools, don't use all of them. Just select the important tool for your team. And then anytime there's too much feedback, then you can actually disable that rule in particular and decide that you will come back later or not care about it. I have a part of the audit at Exacat where I call that the local idiom, the things that you decide. For example, you may decide for echo or print or printf. That could be a religious war if we decide to agree or disagree tonight. But usually for one team or for another, it happens. And when you look at the actual result from the different code bases, there are situations where there's like 95% of everyone using either echo or print or printf. So there's kind of a standard that's emerging naturally. And sometimes it's just not decided. And it may be part of the team, I would say, character to decide which one is important or not. And same for analysis in general. You can decide that adding the parentheses around include or not is important. Well, just let it go, or come back later when you know exactly what you want to do about that.
Very cool. So I'm curious, we've been talking about mainly finding bugs in the code and things like that. And we kind of briefly mentioned that the static analyzers can find security issues. Are there specific tools out there that will help find security issues within PHP code specifically? Or is there some sort of setting we can invoke on any of the static analyzers we've been talking about that will specifically find, like, I'm looking for SQL injections or something like that?
I guess the leader on the market is Lips Technologies. They have this PHP targeting security-focused analyzer that's actually to find problems like SQL injections, code execution, problems related to unserialized. That's one case. Also, there is advisories from Symfony. There is also packages written by Krabios, which is security related. It's firewall, which prevents you from installing the vulnerable packages like Composer. That's a little bit another type of security things.
The whole repository just consists of Composer JSON file with all the conflicting versions.
Yeah, very efficient. I couldn't imagine anything easier before.
That's great. So I'm guessing this is just sounding like the bee's knees for everything that we ever needed to do for our code. So if we just run all the static analyzers on our code and we get our code up to snuff, we don't really need a human review anymore, right? I mean, is that the case?
No, that's well, first you need someone to write that famous code. So you need someone to write the static analyzer. And believe me, there's one degree of magnitude, an order of magnitude higher to write it compared to actually write code. So that's one thing. Secondly, usually I would say static analyzers start with things as low as coding conventions, and it can go up to conception, but you don't know also what you put in the code and why you put it. It's a little bit like saying, if my English grammar is good, then what I'm going to say makes sense. That's not exactly the case. And here it's exactly the situation. So static analyzer will be able to check a number of logical mistakes, math errors, or combinations that are not right in the code. But in the same time, when you reach conception, you don't know if it's the customer who buys something or the furnisher who buys something, or, for example. I'm not kidding. This is a kind of personal experience. But the idea is that at conception level, there are decisions that are completely beyond the scope of static analyzing. So we just have to look at that and say, okay, maybe we can find a paradox here, but that's all.
Yeah, it's just another tool for the box, isn't it? And like, rather than code review, one thing I find incredibly useful, again, going back to the IDE stuff we were talking about before, is that it reduces the cycle that we often go through with PHP. Write some code, save it, go and refresh, see what happened. With static analysis built into your IDE, that just gets so much quicker to do, because rather than typing it, having to save it and go and see your mistake, your static analysis can tell you your mistake as you type in it, you fix it, you carry on going. It's just so much quicker. So
I think that static analyzers can assist you during code review a lot. So it would be really wasteful to waste developer time on finding issues that can be automated. So it would be really wasteful if your developers have to point out different formatting than your coding standard uses, or to point out obvious errors that can be found automatically. But as Damien said, there are still aspects of your code that need to be checked by a human, basically.
So static analyzers are really good at doing their job, but doesn't encompass everything, is what you're saying. I'm assuming, because you have that human aspect, like, does the chair buy the chair or does the human buy the chair? And you also probably have that runtime aspect where this is static analysis, right? It's static code. It's not in the runtime, so we don't get the things like the seg fault error that happens during runtime in PHP potentially that we talked about in previous episodes. But static analyzers probably wouldn't be able to find those types of things, right?
If it's a C static analyzer checking the PHP core code, it could find maybe. Not our end.
That's not intended for the user-land code in PHP applications.
You know what we need to do is combine AI with static analysis and the runtime, and then suddenly we don't even need a human review anymore, and then it covers everything, right?
Hopefully not.
One of the human impacts that static analysis has is the fact that your code is going to be reviewed by something else. So first, if you're a team of one, if you're just writing a little script, but you want someone else to review it, it's not always easy, to go to someone and say, okay, review that and criticize my code. Sometimes you want something else to check it, something that will be completely neutral. And then you look at that and say, oh, and the story I like to mention is that how many times do I improve Exacat? I do some audits on someone else's code. I find something stupid, strange, illogical, whatever. I turn that into an analysis, and usually, what do? I find the same stuff in my own code. So after that, either I have time to fix it, it's simple enough, so then I fix that, and I'm adamant that this is a rule that has to be checked, or I don't have time to check everything, and then I usually say, oh yeah, it's good, and it can be left over. So, but then still, knowing that something else is going to review your code and tell you something is wrong makes you cut much less corner than if you know that it's just going to run and whoever cares.
I liked pointing out issues in other people's code so that I wrote a tool for it.
You automated that process.
Yeah.
That's cool. What did you say, Vladimir?
Same here. We learn a lot. So particularly some things just sent like a gig by communities. Like, Vlad, look what has been fixed here. We make fun and they make rule out of it.
Yes. Well, Damien, when you brought up that point about having someone else look at your code, has you knowing that someone else is going to be judging your code versus just running it against a static analyzer does have a huge effect. If I write something for open source, I write code very differently than if I just write it for code that isn't going to be seen by very many people. And in fact, when I run a static analyzer on it and it finds certain things, I'm like, you know, this is sort of the thing that I like to do. I like to cut these corners with the static analyzers complaining like crazy. And if I had written this in open source, I would have not cut that corner. But I love how it also points out where there's something that I want to be doing consistently, but I'll just miss it in one or two places, like adding class, what do you call it, member visibility on class constants, which we didn't get till 7.1. I think it was 7.1. And the static analyzer is going to find that and be like, hey, these don't have any visibility on them. You should probably define the visibility. And you know, PHP is not going to complain, but the static analyzer will. And now my code can be consistent because it found those two places where I missed it. And I love that aspect about the static analyzers. But I love how you brought up that it's so different when a human looks at it and when a computer looks at it. It definitely changes the way you code.
That's why it's good to run it as part of CI build, because then you can't forget to run it. It will tell you always.
Also, some insight: the most horrible code you can find in the whatever it will be, PHP code or Java code analyzer itself. So I ended because the false positive. I assume that we have all the same trouble, that our code is quite ugly compared to what we force people to do.
So do you do any static analysis on the static analyzer itself?
Of course.
Yes. PHP stun passes PHP stun. And
that's cool.
It often finds errors in itself.
Oh yeah.
That's great. I love a project that can run it on itself, like PHP unit can run on itself. You know, static analyzers can run on themselves. I just love that aspect about certain tools. We kind of need to start wrapping up a little bit. I'm just curious, are there things that you all do to really push static analyzers to a more advanced level other than just kind of running the code and seeing what errors come out?
Can you elaborate a little bit more what you're doing?
Well, are there certain types of integrations that you might put in to a static analyzer or somehow incorporate into the code in a way that's kind of just beyond running the analyzer on a code base and then trying to fix the errors, like maybe adding some automation on top of that, or seeing if it can go ahead and add those visibility properties on class members for me without me having to go in there and do it?
Yeah, I think one of the features I prefer with PHP inspection is the fact that there are quick fixes. So actually, when it finds something that's simple enough to fix, it can just do the work for you across all the application. You just check that everything is fine, and then you validate it. So being able to find, at least for the simplest mistakes, the one that has no choice to make when you're fixing it, then that's really something great.
So I thought about this, but it's really hard. If PHP finds a bug, then how the bug should be fixed. Because, for example, if I find an unused constructor parameter, then I have no idea if it can be removed or if the developer forgot to assign it to a property, for example. So the most bugs PHP stun finds, it's really hard to know how to fix them. So PHP stun doesn't yet fix errors that it finds.
I will not do any self-promotion. It was done already by my colleagues. I just point out to the direction of PHP code style fixer, and its, let's say, predecessor, code sniffer. So code fixer has some risky rules which you can enable, and some of them contributed by me. They kind of the same quick fixes, but they come in by CI level. So if you check the documentation, it says fixer, you can find some things which migrate even your PHP unit level to the new versions. So it can automate. And Code Sniffer has different rule sets, which fits or not, but there is a component tool for Code Sniffer, Code Beautifier, which is capable to fix some of things which are done. But my preference for sure, it's Code Sniffer, Code Style Fixer, because it's, let's say, newer generation, and these guys really save a lot of my time to reformat code in different ways.
One static analysis tool that wasn't mentioned yet is actually PHP-L. It's built-in linting in the PHP executable itself. And what it does is basically just looking for syntax errors per file basis. So it won't tell you that some class cannot be loaded because it has, for example, some abstract methods, or the parent class cannot be found, but it will tell you if you are missing a semicolon. So that's a good first step how to probably start with static analysis in your workflow.
Mm-hmm.
I was just about to ask, where would be the best place to start it? Say if you didn't already use static analyzers, in my experience, it's been as easy as install it and then analyze the code base, right? Like it's pretty much no more complicated than that. Is that pretty much the advice? Is install it and then just run it against the code base and see what happens?
Well, my usually first advice is I actually use static analysis for relaxation. And I really do that. I mean, running the audit itself, it may take a little time or more or less depending on the tool, but then you can do that while you're doing some code. And then you end up with 15 minutes maybe to spare. And then you can take a look at that. The system has already looked into the code, find some interesting pattern, and I just have to do the diagnostic and do the hard part, which is solving the problem if there is one. So within 15 minutes, I have time to go into one place, remove a no-scream operator, turn that into a full-blown exception, and actually catch the exception later. Okay, 15 minutes, that's all I need. And I'm going to make my code better and feel a lot better about it. So if you don't want to go straight into the integration, the continuous integration, well, you can start, manually doing that, having the audit always ready. So if you have some time to lose, go there, look at that, fix one thing, and once you get the habit of it, you will need more automation.
Excellent. Go ahead.
Yeah, actually, just curious who has started at which point with static code analyzer, because for me it started when I started to use PHP Storm. It gives you by default this red things or blue things, or gray, yellow, and I start to research what is this, why it's tied to complaints. Or with the time, it's come to the mind, okay, I do something wrong. You get used, you improve yourself. At some point, you say, okay, that's not enough. I need new challenge. It was my path to what I do. So I'm just curious about other guys.
Yeah, that was the same for me. As I said before, like I tried to go all in on the running the static analyzers as part of CI, and it's just too much to start with. But yeah, when I first started using PHP Storm, I just noticed how useful it was straight away. Built it up from there, got the code bases, passing more, not having as many issues, and then started to use PHP Stan actually quite recently.
It's really eye-opening when you run a static analyzer for the first time, because you thought that your code works, but it turns out that it doesn't at all.
It's just luck.
Yeah.
It's so true. It just shows how forgiving the PHP runtime is. A lot of times when you run a static analyzer, you're like, wow, PHP didn't complain about any of this stuff. It runs just fine, quote unquote. We do need to wrap it up. Any final thoughts on static analysis in the community of PHP?
You have to elaborate once more.
So right now I am in the final phase of the dev cycle of the next version of PHP Stan, which is in development for the past 6 months. I would prefer to have more frequent releases, but turns out it's really hard because once you implement one feature, then you have another idea for a feature that can be based on that. And 6 months later, you have really huge release notes and you have a lot of work to stabilize all the work that you did. So I hope that I will release 0.10 this month. And it will be a huge one.
Very cool. Any other final thoughts on just static analysis in general?
Static analysis is still a young field. There's a lot of ideas around there. We obviously are chasing our own. I have I think a 2000 line to-do file of ideas that I can try here or there, missing some pieces in the current engine, but that will eventually come. So if you want to try one, even if it starts with regex, even though I wouldn't recommend it, but it will work. So give it a try. Try something on your own code. Look how many times you can find violations of things that are important to you. And then at some point, we'll probably have a generalist engine that can work on any code base.
Yeah, some short note on my side. So let's say the last 2 years, it was kind of clear cut that we have next generation of different tools. I would count from the code style fixer, then this PHP Static with my tool, with what Damien doing. That's clearly we have kind of next gen topic, which is just we see how that appears, and difficult to predict which direction it comes to the point. I think it's come to the point that we have a lack of resources, people for development. So with the industry try to optimize and reduce the routine so people can do engineering. Static code analysis here will get own place so people can get rid of these minor things and focus more on engineering things. That's some tendency for generally in our industry. Hope this happens, but who knows?
True that. Well, I would like to wrap this thing up with commenting that you can contribute to the PHP Roundtable by going to github.com/PHP Roundtable and look for a little repo there called show-notes. It has the show notes in Markdown, so if you're comfortable listening to PHP Roundtable while taking notes at the same time, why not just copy-paste them and put them on GitHub? And I will copy-paste all that stuff, put it on the phproundtable.com website, and give you a shout-out on there for contributing to the show notes. And we've had lots of people contribute show notes in the past, and I'm really grateful for everybody's contribution. So thank you so much for supporting the PHP Roundtable. I would like to wrap this thing up. We don't have a developer shout out for this episode, but we will next episode. I got something special for the developer shout out. Really excited. All right, so let's wrap this up with some shameless plugs. Let's start with Greg. Do you have anything you want to shamelessly plug?
No, nothing that can stack up to the work these guys are doing.
No, it's all good. It's all good. All right, Ondřej, you have anything you want to promote?
Probably my Twitter. You can follow me at well, I will not try to pronounce my Twitter username because my Eastern European name and surname is really hard for to spell out. So just check out the show notes and try to follow me from there. And also check out my Medium blog where I blog from time to time, mainly about static analysis.
Perfect. I actually wanted to ask you some specific questions about one of the blogs that you had posted recently about, I think it was, we were talking about doc blocks or something, and it was like the nullable types versus like intersection types or something like that.
Union types versus intersection types, yes.
Yeah, that's what it was, yeah. We'll have to talk about that later, but that'd be another PHP Roundtable, I think. Damien, do you have anything that you want to promote?
Yeah. Well, there is Execat with which we do audits, but I currently have 2,000 open source projects that have been audited by Execat itself. So it's close to 1 billion lines of code. And from there, I actually extract a large number of information. So we have something called the EPIC, the Execat PHP Index of Code, where all the analyses have a frequency. So you know how often, for example, people use the no scream operator, or do they have a stupid plus A minus A equations and stuff like that. We recently had the weird operator list, so very undocumented PHP operators, but we also have the top 100 PHP functions. So if you want to learn about PHP and just focus on the functions that are going to be the most useful to you, well, that's an interesting list. So that plus the list of the 90 static analyzer, and I think I found another one this afternoon, although a static analyzer that found no error on my code is probably not good yet. I'll commit that tomorrow for that, for sure.
True that. Awesome. Well, Vladimir, do you have anything that you want to promote?
Yes, my Twitter account. Sorry for my Russian name. So you can try to find me by my plugin or try to find on Twitter Kalisil. That's me. It's a unique ID for the whole internet. The same as my email. So, and shameless promotion. So we have one open source plugin, PHP Extended A, PHP Inspections A Extended, which is free and stable. I try to stabilize it more and more. And there is commercial one. So if you like Extended and you see the value, or you have a few free bucks, just buy a license for the Ultimate. It has tons of new things about security. So companies who adopted Extended gonna to buy and love the Ultimate.
Excellent. Awesome. Well, our next episode is going to be about secrets. Secrets are no fun. All they do is cause pain when you try to deploy them to production. We're talking database keys, passwords. Well, I don't know, passwords. Things you want to keep secret, API keys, things like that. How do we deploy these to productions and do it in a secure way? We're going to be talking about that and how we're doing it now and how we're doing it wrong the way we're doing it now and how we can change that for the future. If you have something you would like to share on the PHP Roundtable, like a topic that you want to talk about, hit me up. I'm Sammy K on Twitter, or ping PHP Roundtable on Twitter, or go to phproundtable.com and submit the little form that says, I want to join the roundtable, or I got an idea for a topic. I'd like to thank so much Craig and Damien and Vladimir and Ondřej. I'm so bad with names. I apologize for joining us in this episode, and we'll see you folks in the next episode. Peace.